everyone, I'm Jepna from the Discovery Center, and today we're going to investigate how space exploration is impacted by the unique characteristics of astronomical objects. Let's watch as a lander approaches and descends upon an object in our solar system. Landers are carefully designed for the unique challenges they will encounter as they carry out their missions safely and successfully. While watching, look for details that may reveal what object the spacecraft is landing on. The lander is approaching the astronomical object and enters the thin atmosphere heat shield first. A parachute is deployed from the lander to help slow down the lander's descent. As the lander approaches the surface of the astronomical object, its feet extend toward the surface and retro rockets are fired to slow the lander in preparation for landing. The spacecraft lands on the rocky surface. What details did you notice about the astronomical object during the video? What details did you notice about the lander during the video? Based on the clues and information that you gathered from the video, do you have any guesses about which astronomical object the lander was landing on? Our lander was landing on Mars. This is a depiction of the Mars InSight lander. The lander was specially designed to land on Mars based on the characteristics of this planet. The heat shield protects the lander as it enters Mars' thin atmosphere and generates high temperature friction. During this phase, temperatures can reach up to about 1500 degrees Celsius. The parachute helps slow the lander's descent, and the feet will help to absorb shock from landing on Mars' rocky surface. The landing site was chosen for the research and experiments the lander will complete while it's on Mars. What characteristics of Mars impacted the design of the Mars InSight lander? Why is it important to understand the characteristics of an astronomical object before designing a lander? Understanding the characteristics of an astronomical object is very important when designing a lander because it helps determine how a lander gets from space to the landing site on the surface safely. Let's take a closer look at another astronomical object that we know quite a bit about, Earth. What characteristics of Earth would impact the design of a lander? There are many characteristics of Earth that would impact the design of a lander landing on its surface. Earth is a rocky terrestrial planet with a dynamic surface covered in water, mountains, valleys, and more. Earth's atmosphere is thin and made up of different layers that are unique to other astronomical objects in the solar system. These layers help to regulate Earth's environment and temperatures. Earth's mass is also important because it exerts the force of gravity. Gravity is an invisible force that pulls objects toward one another. Anything that has mass has gravity. This table has gravity. This egg has gravity. You have gravity. The more mass an object has, the more gravity it has. Earth has a lot of mass, so it has a strong gravitational pull. All of its mass is pulling on the mass of objects on and around it. Because of the gravitational pull from the Earth, we stay on Earth's surface. When we jump up, we come back down, and when we let go of something, like this egg, it falls to the ground. The gravity we experience on Earth is different than what we would experience on another astronomical object, and it is important to consider when designing a lander for Earth. Why is it important to consider gravity when designing a lander to land on Earth? Design a feature for a lander that will help reduce its impact with Earth's surface as a result of gravity. Here are some of the materials I'm going to use to design a feature for a lander to help it reduce its impact with Earth's surface due to gravity. I have tape, glue, rubber bands, cardboard, construction paper, cardstock, pipe cleaners, aluminum foil, string, and some recyclables. Before I begin building, I need to determine how I will know if my lander was successful in reducing its impact on Earth's surface due to gravity. As we saw before, when I drop an egg from a height of about a meter, it breaks. I'm going to place an egg in the lander and drop it from a height of a meter. If the egg does not break, I'll know that the lander has reduced its impact on Earth's surface due to gravity as it lands. This is just one way to determine if the lander was successful. How else could you determine if the lander has reduced its impact with Earth's surface due to gravity? Here is the lander that I made. What features of my design do you think will help to reduce its impact on Earth's surface due to gravity? What changes would you make to this design? Let's try out my lander. I'm going to put in the egg and drop it from a height of about 1 meter. The egg didn't break. My lander was successful. Try out your lander and see if it can reduce the impact with Earth's surface due to gravity. How will you determine if the lander you made was successful? What other characteristics of Earth may impact the design of your lander? How would they change your design?